Okay, another video. So let's go ahead and take a look at 2 less than or equal to 3x plus 6 divided by 3x plus 2. Okay, so now this one has the problem where, it's not set up the way that we have it with 0. Okay, so what we're going to do, we're going to change it to make it look like 1. Okay, so we're going to have to do a little bit of algebra here. Okay, so we're going to subtract 2 from both sides. It's a little arrow there. Sometimes students don't recognize my arrows. Okay, and so I'm going to say, okay, 3x plus 6 over 3x plus 2 minus 2 should be greater than or equal to 0. That's equivalent. Okay, now we have to do a little common denominator action. Our common denominator is, of course, 3x plus 2. So I'm going to write this as 3x plus 6 over 3x plus 2 minus 2 times 3x plus 2 over 3x plus 2 greater than or equal to 0. Okay, doing a little bit of manipulation. 3x plus 6 minus 6x minus 4 over 3x plus 2 greater than or equal to 0. So what did I do here? 2 times 3x is the 6x. 2 times 2 is the 4. And they both get negatives from here. Okay, so now simplifying this out, negative 3x plus 2 over 3x plus 2 greater than or equal to 0. Now I'm going to do the sign chart. Okay, I'm just going to look at the sign chart here. Where are my zeros? Well, x equals, negative 3x plus 2. I have to figure that out. So negative 3x equals negative 2. X equals 2/3. And the other one, our asymptote, is that x equals negative 2/3. Okay, so let's make the sign chart out. Okay, negative 3x plus 2, 3x plus 2. All right, negative 3x plus 2, that is a 0, or it gives you a 0 at 2/3. Okay, 3x plus 2 gives you an asymptote at negative 2/3. Okay, now here's where things are going to be a little bit different than we've seen before. This is a line that slopes down, right? Our slope here is negative 3. So that means our sign chart's actually going to start positive and go negative there. All right. Then the other one is the way we know it, the way that all of the other ones have been. Okay, goes from left to right, slopes up. So, positive, negative, negative, positive, negative. We are asked, when is this greater than or equal to 0? Okay, now just as same as going off the sign chart. Negative 2/3 to 2/3. We do not include the negative 2/3. Why? Because that was an asymptote. Okay, that one's not in the domain of this expression. We do include the 2/3, however. Okay, let's look back at the original expression. The original expression had a division by 0 problem at negative 2/3, which we have carried through to the end of the problem. Okay? All right, let's do another one just to get practice. same sort of thing. A little slightly different, but same idea. X minus 7 over x minus 5 greater than or equal to x plus 5 over x plus 3. I understand the impulse to want to cross multiply, but it's not going to give us anything worthwhile. I mean, we could do it, but it's not going to really help, okay? So we're going to end up having to add or subtract fractions anyways. So we may as well just do it this way. So x minus 7 over x minus 5 minus x plus 5 over x plus 3 has to be greater than or equal to 0. I'm going to write down, just so that I make sure, x cannot equal 5, x cannot equal negative 3. I just want to keep that sort of in mind for this problem as I'm going forward, because they might go away in the algebra, and we don't want that. We don't want to lose them. Okay? So now, common denominator. What's our common denominator? X minus 5 times x plus 3. Doesn't look like they're going away yet, so that's good. So now, what is missing here in order to get the common denominator? We need the x plus 3 term, right? We need that x plus 3 term. So x minus 7 times x plus 3 minus, what's missing here to get the common denominator? We need the x minus 5 term. X plus 5, x minus 5. All right, so now we're going to do a little just multiplying it out. X squared minus 4x minus 21 minus x squared minus 25 divided by x minus 5 times x plus 3. I don't mess around with this because our denominator is already in factored form. Okay, so the factored form is sort of the way we want things to be. Okay, this numerator is not really in factored form because of this minus you have. You have to combine them. Okay, so we have to combine them, and then we're going to have to factor it. All right, but it's going to end up not being that hard here. Okay, the x squareds cancel. Negative 4x plus 25 is going to be negative 4x plus 4 over x minus 5, x plus 3 greater than or equal to 0. Let's factor out that negative 4. I don't like it in there. So negative 4, x minus 1, x minus 5, x plus 3 greater than or equal to 0. And now I'm going to make my sign chart. So where are my roots? I have negative 3 is an asymptote, 1 is a root, 5 is a root. I'm going to put the negative 4 as its own little thing. X minus 1, x minus 5, x plus 3. X minus 1 gives you a 0 at 1. X minus 5 is a asymptote at 5. X plus 3 is an asymptote at negative 3. Okay, negative 4. Negative 4 is always negative across the board. It's going to give you a negative in your sign chart. x minus 1. This is a slope or a line sloping up with slope 1, so it changes from negative to positive. X minus 5 changes from negative to positive. X plus 3 changes from negative to positive. 4 negatives gives you positive. 3 negatives gives you negative. 2 negatives gives you positive, negative. So when is this greater than or equal to 0? Well, between -3 and 1, we do not include the -3, but we do include the 1, together with, why am I doing that? My bad, my bad, my bad. Greater than or equal to 0. Oops. Between -infinity and -3. See, even after all these years, I still have to be paying attention, because if I don't, I'll make a silly mistake like that. Then you'll all be like, he made videos and he didn't even correct his mistakes. I mean, I did correct my mistake, right? But, okay, never mind. Then from 1 to 5, and we include the 1, but we do not include the 5. Okay? All right, that's it for section 2.5. I'll see you guys soon.